Hello students and welcome back. Let us design one more system using finite state machines, and that is up-down counter. So in this video we are going to talk about up-down counter using the concept of states. We are going to design it using finite state machine and implement in the Verilog programming language. So let us get started. So first of all, as we know about up-down counter, the counter can count in both the directions. The number of states will be 4. We are going to count from 0 to 3. The input will decide the direction of counting, whether we are counting up or down. If input is 0, we will count up, and if it is 1, we will count downwards. So the state table is very simple. We are having our present state S0, S1, S2, S3. These are the 4 values. If the input is 0, we are counting up. S0 goes to 1, 1 goes to 2, 2 goes to 3, and 3 goes to 0. If the input value is 1, then we count in the downward direction. That means 0 will go to 3, 1 will be going to 0, 2 will go to 1, and 3 will go to 2. And the outputs are independent of input. They completely depend on the present state. Now let us construct it. We have S0, S1, S2 and S3. Outputs are written inside the state names because it is a Moore's machine. So we say if the input is 0, then we go to S1. We don't need to write slash something because output is already written inside the state name. From S1, if input is 0, then we go to S2. From S2, if the input is 0, we go to S3, and from S3, if the input is 0, we go to S0. From 3, if the input is 1, then we go to S2. From 2, if the input is 1, we go to 1. From 1, if the input is 1, we go to 0. And from 0, if the input is 1, we go back to S3. This is how we can construct the state diagram as well from the state table. Now we are going to implement it in Verilog using Vivado. The code is very similar to what we have done earlier for a normal one direction counter, but we take direction as one of the variable instead of D in. Rest of the things are pretty much same. We have inputs clock, direction and reset single bit. Output is Z, which is 2-bit register, and we take state as a 2-bit register. We define 4 parameters S0, S1, S2, S3, and the numbers values are 00, 01, 10, 11. Now as usual, first of all we define the reset case. If reset is 1, state goes to S0, otherwise state remains in the same value. Now we are going to define the case statement for all the 4 states. There is something different that I have done this time. I have written the assignment of Z inside the same case because it is a Moore's machine. The output depends only on the state value. So we say if direction is 1, count down, 0 goes to 3, otherwise 0 goes to 1. And irrespective of this if else, the output is 0. When we go to the next ones, we have very similar pattern. In S1, if I count down, I go to S0, otherwise I count up to S2, and output in S1 will always be 1. In S2, the output is always 2, count up will take me to 3, count down will take me to 1. And in S3, the output is 3, count up will take you to S0, count down will take you to S2. Now simulations. In the simulation, first of all, we have to keep reset equal to 1 so that we get certain value of our counting and we get 0. After that, I have set my direction to 0. 0 means we are counting up. So you can see 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. We keep counting up. Now, what I have done, after some time, I have set the value of direction to 1 and we start counting down. We are counting down 3, 2, 1, 0. 3, 2, 1, 0, 3, 2, 1, 0 and so on. If I change the direction back to 0, we will start counting up. So students, now we know about up-down counter. Let us have one more system and which is similar to the earlier discussed one, which was pattern detector, but this time we are going to do that using the Mealy machine. Keep learning. Thank you.